ever stopped to wonder what actually powers our super fast real-time world? Well, there's this kind of invisible engine running everything behind the scenes. It's called event-driven architecture. And it's the magic behind all those instant, seamless experiences we pretty much take for granted now. Let me show you exactly what I mean.
Think about it for a second. An item gets added to your shopping cart. A stock price on your screen changes in a flash. And boom, a notification for a new message pops up on your phone. All of that happens in the blink of an eye. So what's the thread connecting all these completely different, instantaneous moments? The answer is a really powerful design pattern that has totally revolutionized how modern software is built.
Okay, so here's how we're going to break it down. First, we'll cover what EDA actually is. Then, we'll follow the journey of a single event to see how it works. After that, we'll get into why this is such a game changer, check out where it's being used, and finally, look at the bigger picture.
First things first, what exactly are we talking about here? It's really all about a big shift in thinking, moving away from systems that just sit on static data to systems that are built for dynamic, real-time action. At its heart, event-driven architecture is a design model that's built to spot things happening and react to them, as they happen. So instead of one system constantly pestering another one, saying, "Hey, anything new yet? How about now?" The system itself just announces, "Hey, everyone, something just happened." And that lets everything else respond instantly. And what's an event? It's really just a simple record that something happened. It could be you clicking a button, a sensor in a factory noticing a change in temperature, or a customer completing a purchase online. Each one is just a tiny little packet of information that signals a change. And don't make the mistake of thinking this is some niche futuristic concept. A recent study found that over 72% of organizations across the globe are already using EDA. It's basically become the foundational plumbing for our entire modern digital economy. So how does it actually work under the hood? Let's follow one single event on its journey through the system, from the moment it's born to the moment it actually triggers an action.
The best way to think about it is like a really sophisticated mail system. First, a letter, which is our event, gets written. We call that production. Then it goes to a central post office to get sorted and sent to the right address. That's the routing. And finally, the letter gets delivered and read, which causes someone to do something. That's consumption. The journey starts with the event producer. This could be anything, really. Your phone, a factory sensor, or an e-commerce website right when you click Buy Now. Its only job is to see that something happened and announce it. But here's the key. It doesn't know who's listening. And frankly, it doesn't care. Next up, that Buy Now event lands at the event router. Think of this as the system's central post office. It takes in all the events from everywhere and directs them exactly where they need to go, all without the original sender and the final destination ever having to talk to each other directly. And that brings us to the final stop, the event consumer. This is any part of the system that has basically subscribed to certain types of events. So when that Buy Now event shows up, the inventory system consumes it and updates the stock count, while at the same time, the shipping department system consumes it and starts preparing your order. Okay, so this whole structure where nothing was directly connected, we call that decoupled, is the real secret sauce. Let's look at why that independence builds a fundamentally different and just way more powerful kind of system. This right here is the fundamental shift. See, traditional systems work like a phone call. Service A calls Service B and then has to wait on the line for a reply. They're stuck together. But EDA works like sending a text message. A producer can just fire and forget an event and then move on. This is a huge deal because it means different parts of the system can be updated, scaled, or even fail on their own without bringing everything else crashing down. This fire and forget approach leads to some massive advantages. Let's talk scalability. If 1 million people suddenly place an order, you don't need 1 million cashiers. You just add more listeners to process all the orders from the queue. The system just scales. Or think about reliability. If the service that sends email receipts goes down, it doesn't stop you from taking new orders. Those events just wait patiently in the queue until it comes back online. The system is naturally fault tolerant. Now, this all sounds pretty great in theory, right? But where is this actually making a difference? Let's connect this whole idea to the services you use every single day. The applications are literally everywhere. From the second you place an e-commerce order, which triggers a whole cascade of events for payment, inventory, and shipping, to the stock market where every single trade is an event processed in microseconds, it's in online gaming, ride-sharing apps, and even the fraud detection that's protecting your bank account. They all run on these same event-driven principles. Now, EDA isn't just one monolithic thing. There are different models, and just like any powerful technology, it definitely comes with its own set of challenges and trade-offs. Broadly speaking, there are two main flavors. You've got publish-subscribe, which is kind of like a live radio broadcast. Subscribers tune in, and once the message is heard, it's gone. Then you have event streaming, which is more like a podcast. Events are saved to a permanent log so new systems can tune in later, go back, and replay history. This is incredibly powerful for things like analytics or recovering from a system failure. But all this power comes with trade-offs. The very same independence that makes EDS so flexible also makes it more complex. It can be way harder to trace a problem through a dozen disconnected services, and you have to deal with challenges like eventual consistency. You know, the idea that if you update your profile picture, it might take a few moments for that change to show up everywhere. You gain incredible power and scale, but you have to manage this new kind of complexity. This quote really gets to the very heart of the EDA philosophy. It's about recognizing that, in our world, the value of information is often highest in the exact moment it's created. A fraud alert is valuable right now, not in an hour. EDA is built from the ground up to capture that immediate value. And that leaves us with one final thought to chew on. As everything from our cars to our supply chains becomes more and more interconnected and real-time, the question is no longer if systems will be event-driven, but what systems won't